All right, IB Physics, Ms. Getz here, and today I'm going to help you go over this free body diagram problem from 6.2. So we're going to look at number 7 because it's a pretty challenging problem. And I'm going to go ahead and get rid of this stuff so it doesn't get in my way of solving this problem. This problem, we have this 156 Newton light fixture supported as in the figure. Ta-da! And it says, find the tension in the supporting wires. So we have two supporting wires, and I'm just going to add in a little bonus to the picture before I even start solving the problem. If I know the angles up there are 38 degrees, that means that the angle down here is also 38 degrees. So just as a, remember the, congruent lines, intersecting lines, it's a math. There's some sort of law, but I can tell that those are also going to be 38-degree angles. So that's just a little bonus I'm starting in with at the beginning. So when we're solving these problems, it's really useful to use these different tools. A force web is a tool where we're going to go ahead and draw a little picture that says, okay, well, the objects in this situation, I've got the lamp, I've got the wire, and there's actually two wires, so I'm gonna have wire 1, wire 2, and then I've got the whole earth. And so all of those are objects. So remember, a force web, the objects go in circles, and then we show the connections as lines between them. So the connection between the lamp and the earth is a gravitational force. The connection between the lamp and wire 1, that's going to be a force tension. Lamp and wire 2, that's also going to be a force tension. And you might say, Ms. Getz, what about the ceiling? The ceiling is there, but you know what? It's not interacting with the lamp, so I don't actually care about it. So that's my force web. And then I'm going to move on to my free body diagram. As you become aware of forces and you feel pretty comfortable and confident with them, you'll find that you don't need the force web as much to help you make the free body diagram, but it's a good place to start out. So my free body diagram, here's my lamp. It's a dot. I'm going to go ahead and have my gravitational force straight down. And then I'm going to show those two tension forces, and I'm going to make sure to show them at the correct angle. So I'm going to call this one force tension 1, just because it doesn't actually matter which one I call which. And this one I'm going to call force tension 2. So I've got these two tension forces supporting the lamp. So I've got my free body diagram all set. And then we're going to use our sum of the forces table. And that is where we have a little table that has the sum of the forces in the x direction and the sum of the forces in the y direction. And just by glancing at my free body diagram, I can see that there's one force in the y direction completely, and that's force gravity. So I'm going to go ahead and add that onto my force table, force gravity, and that's negative. And then there are these tension forces, and annoyingly, they are at an angle. So that means that each of them has a component in the x direction. So this is force tension 1 in the x direction. And it has also a component in the y direction, force tension 1 y direction. And I can say that those should go into my table. So in the y direction, force tension 1 is up, so it's positive. And then in the x direction, force tension 2, I missed the y at the end of that, I'm sorry. Y. Force tension 1 in the x direction, Ms. Getz. Oh my gosh. Subscripts, I'm doing the most. But they're really useful for keeping track of which one we're talking about. So force tension 1 in the x direction, and that's going backwards in the x direction. So that's going this way in the negative x direction. So I'm going to call that negative. And then I'm going to go ahead and draw in the same components for the force tension 2. So that has a positive force tension 2x, and then it has also an upwards force tension 2y. And I can add those on to my force table. Force tension 2y, and then I made that one orange. And it's going in the positive x direction, so force tension 2x is positive. Whew. That was doing the most. So I have now written down each force and each force in its component parts in the x and y directions. And I know that these forces have to add up to 0. First off, because we're in the unit balanced forces, and second off, because the lamp, it's just like hanging there. It's not falling or flying up into the air or something. So that means that the forces on it are balanced. They're going to add together to 0 newtons. And so we have to start off by making, from our force table, we can actually make our equations for the forces in each direction, or the sum of the forces in each direction. Because again, I'm aiming to find this tension force, and to do that, I'd have to know its x component and maybe its y component and combine them together. But we'll make some equations and see how it works along the way. So I'm going to start out with my x direction. The sum of the forces in the x direction is equal to, and I'm going to start right here just because it's the positive one, and I'm not going to keep color coding because I think it'll take me too long. So force tension 2 in the x direction minus force tension 1 in the x direction equals 0. So together those equal 0. I can add this force over to the other side of the equation. And so that tells me that force tension 2 in the x direction is actually equal to force tension 1 in the x direction. So that's cool. That is actually telling me that these two forces are congruent. They are the same length. And that can tell me that mathematically, if these two are congruent and these two angles are the same, which they are, they're those 38-degree angles, that tells me that the force tensions are the same as well. So that is telling me that force tension 1 equals force tension 2. And I don't even have to worry about the x direction anymore. And you might say, oh, but Ms. Guts, how will we ever find the x direction? You're right, it would be really great if we could find the x direction. But because we don't actually know any values in the x direction, it's going to be impossible for us to find it from the x direction. So that means that I'm going to shift my attention over to the y direction. I'm going to start with my sum of the forces in the y direction equation. And that I'm actually going to start, I'm not going to start with negative gravity just because, again, I don't like starting an equation with a negative number because often you forget to include the negative. So that'll be force tension 2 in the y direction. But it doesn't matter anymore that it's 2 and 1 because they have to be congruent. So, in fact, I'm just going to write in force tension in the y direction, that green one. Then that other force tension in the y direction. And then that negative force gravity. And I know that all of these are going to add up to 0 newtons. So from this equation, I can see that I have two terms that are force tension in the y direction. I'm going to call that 2 force tension y minus Fg equals 0 newtons. And actually, I can add Fg over to the other side. And what I get is that 2 times force tension in the y direction is equal to the force of gravity. And that's nice, like we're making this equation. Does that actually help us solve the problem though? So let's take a moment and see what the problem gave us in the first place. Well, we know the angle, check. And that I have in this picture, and so that'll be this angle on these tension forces. We also know that it's a 156 Newton light fixture, and that means that is the gravitational force, Fg, on the lamp. So I know that this equals 156 newtons. And I can go ahead and divide by 2. And 156 divided by 2, that's 75 plus 3, which is 78 newtons. And you might say, yes, we're done. But we're not quite done. Because if we divide it by 2 here, what we found is the force tension in the y direction. And what we actually need to find is the total tension force. And so to do that, again, I'm going to make my little equation here a little smaller. Move it to the side. To do that, I have to then say, okay, if I know that the force tension Y equals 78 newtons, then can I find force tension in the x direction? And the answer is, of course you can, because we know that our tension force, both of them, are going to be congruent, so I don't have to solve it twice. I have the x component, I have the y component, and I actually know the y component is 78 newtons. And so I want to find this total force tension. So I'm going to use my old friend, SOHCAHTOA, to do so. So let's grab a new color just to make it a little easier to track. So that's not a new color. SOHCAHTOA. So we know that this is opposite the angle, and I would like to find the hypotenuse. So that means that I'm going to go ahead and pick sine, which is the opposite over the hypotenuse. And I'm going to actually write that out in full for you. So I'm going to say sine of 38 degrees is equal to the opposite side, 78 newtons, over the hypotenuse, force tension, that's what we want to find. And I'm going to go ahead and try to solve for force tension. So notice that force tension is not in the numerator right now, not in the top. So I'm actually going to multiply it on both sides. Ms. Getz, turn your phone to silent before you take video. Oh well. Then force tension is canceled out here. Now I have force tension times the sine of 38 is equal to 78 newtons. And I need to divide by sine of 38 on both sides. I am showing every single step of my algebra here, and when you're first solving these problems, I would really like you to show every single step of your algebra. So then I'm going to go ahead and plug that into my calculator, 78 newtons divided by sine of 38 degrees. I'm going to make sure that my calculator is in degrees rather than radians. If it says degrees at the top or something, it is. And I have an answer of 126.69 newtons. So that I'm actually going to round up to 127 newtons. And that is the force tension in both of these ropes. Because they're both at the same angle, they're going to have the same force tension, which we proved by looking at the values in the x direction. That means I'm coming close to my 15-minute timer, and we solved the problem. So as you're doing these, make sure you have a clear free body diagram, and any force that is at a funny angle with respect to the x and y axes, you break into its x and y components, and then put those in your sum of the forces table. When I'm scoring these, I'm going to look for this table, and I'm going to look for these sum of the forces equations written out, notice, in letters, not in numbers, until I get to where I'm doing some solving. So good luck, folks. I know these are challenging, but you can do them. 36 seconds left.